The Smart Monitoring Workflow is a part of the Digital Earth Flood Event Explorer. The Digital Earth Flood Event Explorer, which has been developed within the Digital Earth project, assists the investigation of flood events along their process cascade based on digital workflows. The goal of the Smart Monitoring Workflow is first to support experimentalists to determine the most suitable time and location for event-driven ad hoc monitoring in terrestrial hydrology, and second, to provide tailor-made access and automatized processing capabilities to data from diverse public databases. We use the short-term planning of soil moisture measurement campaigns using vehicle-mounted cosmic ray neutron detectors as a demonstration scenario for our smart monitoring workflow. This measurement technique allows to study spatial soil moisture variability on larger scales, but determining the optimal date and route to drive is challenging, in particular in an event case like a storm with short lead time providing short-term event data. Within the smart monitoring workflow, first a region of interest, for example an interesting river basin, can be added to the workflow by adding an empty thematic layer in the Layers panel. Use the Draw and Modify function to mark a region on the map. Alternatively, GIS vector files containing a polygon can be added directly to the workflow by drag and drop. Like in our example, a polygon describing the shape of the Müglitz River basin. For the further analysis, the region of interest can be determined by selecting one of the vectors layers from the Layers menu and pressing the Set as Region of Interest button. Similarly to vector layers, datasets containing gridded information can be also added via drag and drop to the workflow directly. For instance, this dataset containing information about the clay content in the soils of the Müglitz River basin. In the Layers menu, options are given to, for example, changing the color scheme of the visualized data, and also threshold filters can be applied to highlight the cells belonging to a certain data range, e.g. all cells belonging to the 25% of the highest values of the distribution. Clicking on Apply, only these values are visualized. The Smart Monitoring Workflow provides an interface to public databases via the Thematic Layers panel. On the one hand side, data can be directly integrated from the databases that support the OGC Web Interface standards by simply adding the URL and the credentials. Alternatively, datasets such as the precipitation record of last week and the upcoming weather prediction can be directly selected from the Layers from Catalog menu and added to the workflow by pressing Add. The downloaded datasets are automatically integrated in the Smart Monitoring Workflow. The Smart Monitoring Workflow provides raster statistics functionality for time-variant datasets. For example, to get the sum of precipitation recorded within the last week, go to the layer Precipitation of the last 7 days and select from the raster subset functions the function provide sum over all time steps. After finishing the calculation, a new layer appeared, which gives you the sum of all precipitation recorded in each cell for the last 7 days. The Temporal Analysis menu assists the user to find the optimal date to initiate its measurement campaign. It provides the opportunity to analyze time series of variables spatially integrated over the pre-selected region of interest. The user can decide between the parameters from weather prediction models and the predicted overpasses of environmental satellites. The display diagram of the time series helps the user to find a suitable date for his campaign. For instance, if he wants to synchronize his measurements with datasets provided by the Sentinel-2A satellite, the 23rd of January may be a suitable date for his campaign. Or if he needs dry conditions for his measurement, he should not do his measurement in the morning of that day. The weighting functionality of the Smart Monitoring workflow enables to merge selected raster input datasets using multiple linear regression. By clicking on the menu Weighting, the weights can be defined by the user, but have to sum up to 1. Using the input dataset, clay content of the Müritz area and precipitation of the last 7 days, and choosing equal weights of 0.5, a new raster is computed after clicking on Weighting. The appearing raster shows that in 5 regions, which are highlighted in blue, a comparatively large precipitation and clay content exists. Thinking about our target variable soil moisture values may be larger there than in the surrounding. These areas can be extracted from the weighting raster by setting a threshold filter in the Layers menu. A driving route can be directly calculated to go to each of the areas by pressing the Calculate Route button in the Layers menu. A new window appears where additionally a starting position can be defined by the user, which for example could be the working place. One option is to pick the location directly from the map. In our example, we will start our route in Diepholzwalde. Afterwards, a request is sent to the backend. After the calculation, the route is shown in the map as a vector file, and it aims to find a time-optimized route between all measurement locations. This route, which was calculated using the OpenStreetMap road network data, can be downloaded and integrated into automotive navigation systems of your measurement vehicle. Summarizing, the smart monitoring workflow supports scientists with adaptive campaign planning, in particularly during events when response times are small. At a later stage, the workflow will be able to embed data products and analytical capabilities provided by the 4 other workflows within the holistic concept of the Digital Earth Flood Event Explorer.